Hello everybody. So today we will revise D and F block. Okay. So we all know that D and F block is a part of inorganic chemistry and it's a part of 12th standard, right? Also, if you check NCRT in D and F block elements, I mean in this chapter, everything is there. That means there has been no deletion. So every subtopic is important from the point of view of NEET, which means you are supposed to study NCRT thoroughly for this topic. It's an important topic. Nothing has been scrapped off. So we need to ensure that we are thorough with the content of NCRT in this chapter. There are reactions in this chapter. There are trends. There are different compounds, right? There are subtopics related to stability and other properties, which means we have to ensure that we are thorough with the entire chapter. Now, usually we are thorough with, like, some of us are very comfortable with D block, but we are not very comfortable with F block elements, right? I mean the lanthanoids and actinoids. So sometimes we are not very comfortable with lanthanides and actinides, but it's okay because there are only a few concepts related to F block elements in NCRT. So there is no need to go in great depth, but yes, whatever is given in NCRT has to be studied. So we will cover questions pertaining to F block elements as well in today's session. Okay, so let's start. So the first question is, in aqueous solution, EU2 plus acts as. Okay. Now this EU2 plus is what? It has an oxidation state of +2 and EU is europium, right? It's an F block element. Okay. Now see, EU2 plus has a tendency to get converted to EU3 plus. Right. What does this mean? This means that this is more stable than this. That means +3 oxidation state is more stable than +2 oxidation state for europium. Right. That means this is getting oxidized. Hence, I will say that EU2 plus is acting as a reducing agent. So option B is the correct answer. This is more stable oxidation state than +2. Next question. The most characteristic oxidation state of lanthanides is. So again, they have asked us to identify the most common oxidation state, that is OS, of lanthanides. Now, lanthanides are also called lanthanoids. And answer is +3. So option B is the correct answer. The most common oxidation state is +3 for lanthanides. This is a very easy question. Let's move to the next question. The common oxidation state of actinides is, again, it is +3. These are also called actinoids. So +3 is the answer for lanthanides as well and for actinides as well. Okay. Next question. Which of the following pairs has elements having almost similar sizes? Very, very important. Almost similar sizes. Now see, this concept is discussed in periodic classification of elements, and I mean that chapter called classification of elements and periodicity, that is in 11th standard. This concept is discussed because we discussed lanthanide contraction there, right? And we know as a result of lanthanide contraction, NB and TA have similar sizes, that means almost the same size. NB is niobium and TA is tantalum. and Ta is tantalum. Right? So Nb and Ta have similar sizes, and the reason is what? Lanthanide contraction. Similarly, if you remember, Zr and Hf have similar sizes. Zirconium and hafnium. This is zirconium, this is hafnium. Atomic number of zirconium is 40, and the atomic number of hafnium is 72. Now, one more interesting thing if you see here as well as here. Look at this option. Okay, look at the atomic numbers. So 41 plus 32 is 73. That means the difference in the atomic numbers is 32 because one element lies below the other. We are talking about the same group, right? Similarly, if you talk about Hf and Zr, 40 is the atomic number of Zr and 72 is the atomic number of Hf. So 40 and 72. Again, if you look at the difference, it is 32. So 40 plus 32 is 72. Forty plus 32 is 72, right? That way. So again, Zr and Hf belong to the same group of periodic table. Next question. Okay. So this is based on the same concept. Hf and Zr, that means Hf4 plus. Hf4 plus is this ion, right? Within brackets we have mentioned 4. That means oxidation state is plus 4. This is stock notation, right? And same holds true for this. Right? So lanthanide contraction is the reason just now we discussed. See, 0.75 angstrom and 0.74 angstrom are almost same. So Hf4 plus and Zr4 plus have almost the same size. So the reason is lanthanide contraction. Hence option B is the correct answer. Alright, next question. In which of the following pairs are both the ions colored in aqueous solution? Atomic numbers have been provided. Right? Atomic numbers have been provided. If I talk about electronic configuration of Ni2 plus, right? I'm talking only about 4s and 3d here. So if you remember, 4s2 3d8 is the outer electronic configuration of nickel atom, but now it is plus 2, so I have to remove 2 electrons, which means this is what we get. Similarly, let's talk about Ti3 plus. Ti3 plus. Ti is titanium. Atomic number is 22. So 4s2 3d2. But then it is plus 3. So if I remove 3 electrons, I have to remove 2 electrons from here and 1 from D. So I'll be left with this. So 3d8 will be shown like this. So these are unpaired electrons, and similarly for 3d1 also. So if you look at the number of unpaired electrons, then in Ni plus 2 there are 2 unpaired electrons, and in Ti plus 3 there is only 1 unpaired electron. So yes, we have unpaired electrons, and hence these ions will be colored. Both Ni2 plus and Ti3 plus will be colored because of unpaired electrons. Next question. Okay. More number of oxidation states are exhibited by the actinoids than by the lanthanoids. The main reason for this is, So the main reason for this is lesser energy difference between 5f and 6d orbitals than the difference between 4f and 5d orbitals. So C is the correct answer. It's an important question. It can be asked in the form of assertion reason also. So we should know this as a concept. Hence C is the correct answer for this question. Next question. Which of the following ions is the most stable in aqueous solution? Most stable in aqueous solution. So it is a concept based on stability. Based on stability. Now, if we check these ions, we have V3+, Ti3+, Mn3+, and Cr3+. This is the correct answer. Cr+3 is the most stable out of all these, because if you check, +3 is the oxidation state for every ion here. So the stability of +3 is highest for chromium out of all of these. Hence D is correct. Next question. Identify the incorrect statement. Incorrect. That means which is wrong. Identify the incorrect statement. Okay. First statement is lanthanide contraction is the accumulation of successive shrinkages. That is true, because as we travel from 58, that is cerium, to lutetium, 71 is lutetium, there is continuously a decrease in the atomic and ionic radii. So it's shrinking, accumulation of shrinking, right? Accumulation of successive shrinkages is happening because every element is smaller in size than its predecessor. So this is a correct statement. Next statement. As a result of lanthanide contraction, the properties of 4D series of the transition elements have no similarities with the 5D series of elements. Now this is incorrect, because there are very much similarities between the elements of 4D series and 5D series, because if you see, what happens is the elements of 4D series and 5D series belonging to the same group have similar sizes due to lanthanide contraction, so properties will be similar, whereas they have written no similarities. This is an incorrect statement, hence B is the correct answer, because we have been asked to identify the incorrect statement. Shielding power of F electrons is very weak. Obviously, F and D electrons have poor shielding effect, so C is correct. And then we have discussed D already, hence correct answer is B. The only incorrect statement is B. Next question. The element with which of the following outer orbital configurations may exhibit the largest number of oxidation states? Okay, now let's look at these elements. If you check, all of these belong to the 3D series, because you have 4s3d, 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 and 4s3d. So all of these belong to the 3D series. Now what is 3D series? 3D series has elements from Z equal to 21 to Z equal to 30. That means from scandium till zinc. This is what? This is for, so 22. So this will be 22. So titanium. What about this? 23. Vanadium. Right? 24. Chromium. Manganese. Now we know that out of these, manganese has the maximum number of possible oxidation states. Hence D is the correct answer. Manganese has the highest number of oxidation states, so D is the correct answer. Next question. Which of the following oxidation states is the most common among the lanthanides? So we have discussed this already. +3 is the most common oxidation state for lanthanides as well as for actinoids. Next, which of the following pairs has elements having the same size? Again, same concept, right? So D is the correct answer. We have discussed this already. This is the result of lanthanide contraction. So Zr4 plus and HF4 plus have the same size, almost the same size. Zr is zirconium, HF is hafnium. This is the spelling of hafnium. Right? Next question. Which of the following ions has electronic configuration? Argon 3d6. Okay. Now, argon is having 18 electrons, so in total there are 24 electrons now. But then hold on, this is an ion. Ion, right? We all know that if we have an atom of 3D series, then this is how the filling takes place according to Aufbau principle. 4s gets filled before 3D, right? Which means 2 electrons will be there here, and then we have the remaining electrons in 3D. Unless it's chromium, because for chromium we know it's an exception. There is 1 electron in 4s and there are 5 electrons in 3D. And also for copper, 1 electron is there in 4s and 10 electrons are there in 3D. Now see, we will write down the electronic configuration for each. So for this one, it's argon, cobalt is 27, so 27. But there are the charge is plus 3 here, so that means we have to remove 3 electrons from cobalt. So I'll remove 2 from 4s and then I'll be left with this. So I've got it. This is what has been asked for. For each of these I can write, but there is no NEET because we know that there is only one correct option for NEET. So A is the correct option. Right? For all of these again we can write in the same way. That means we first write the electronic configuration of the neutral atom and then we remove the required number of electrons in order to make it positively charged. While removing electrons, please remember that we have to remove electrons first from 4s and then from 3D. Don't start removing electrons from 3D. You have to start removing electrons from 4s. So A is the correct answer. Next one. Which of the following will exhibit color in aqueous solution? So, if we know that there are unpaired electrons, then definitely color will be shown in the aqueous solution. Let's try for this. Ti3+. So for titanium, we can write the electronic configuration. The atomic number of titanium is 22. But this is Ti3+. What I have written just now is for titanium. Ti3+ indicates that I have to remove 3 electrons. So let's remove 3 electrons now. And once I remove 3 electrons, this becomes the electronic configuration. Now, there is one unpaired electron and hence this will be colored. It's an unpaired electron and hence Ti3+ will be colored. So C is the correct answer. Next question. For the 4 successive transition elements, chromium, manganese, iron and cobalt, what is the order of stability of +2? Take care of this, not +3, +2. +2 oxidation state in gaseous state. Now see, you have to remember the order of stabilities of +2 oxidation states and +3 oxidation states for the elements of 3D series. Right? So you have to keep this in mind. So the correct answer is A. Now, we all know that Mn2+ is extremely stable. So, out of all of these, Mn is the most stable one. There is only one option where you have Mn in the beginning. There is no other option where the first element is Mn. So, that means Mn2+ is more stable than Fe2+. Fe2+ is more stable than Cr2+, and Cr2+ is more stable than CO2+. Hence A is the correct answer, right? Next one. When KMnO4 reacts with bromine in weak alkaline medium, this is the important term, weak. That means mildly alkaline. It's not a very strongly basic solution. It is mildly alkaline, so weak alkaline solution. Bromate ion is formed, then oxidation state of manganese changes from +7 to. Okay, now we know that in KMnO4 we have MnO4 minus. This is called permanganate ion. What is this called? This is called permanganate ion. Now this permanganate ion is reacting with bromine. And the medium is basic, but it is mildly basic. Okay. Now we know that in mildly basic solution, MnO2 is formed. And in strongly basic solution, that means if it is extremely basic, then manganate ion is formed. That is MnO4 2 minus. See, this is called permanganate ion, this is called manganate ion. This will be formed when the medium is strongly basic. And this is obtained when the medium is mildly basic. Let's find out the oxidation state of manganese here. It's +4, right? And here the oxidation state of manganese is +7. So from +7 it changes to +4. B is the correct answer. If you look at this, then it is +6. So they can ask you n factor of KMnO4 in mildly basic solution or also in strongly basic solution. So what is the n factor of KMnO4 in mildly basic solution? So the n factor of KMnO4 in mildly basic solution will be 4 minus 7 and then the modulus, so 3. So I will say that the n factor of KMnO4 is 3 in this mildly basic solution, whereas the n factor of KMnO4 or MnO4 minus is 6 minus 7 and then modulus, so 1. The n factor of MnO4 minus is 1 in strongly basic solution because we are getting this. Okay. MnO2 is called manganese dioxide. So here correct option is B. Next question. Which of the following statements is not true? Okay. Which of the following statements is not true? K2Cr2O7 solution in acidic medium is orange. Okay. Now see, K2Cr2O7 has this. This is called dichromate ion. This is called dichromate ion. Okay. So we have to understand the concept. I mean the concept related to K2Cr2O7. So K2Cr2O7 is potassium dichromate. Okay, then so option A is correct. So yeah, it is orange. Now next one. K2Cr2O7 solution becomes yellow on increasing the pH beyond 7. Beyond 7, that means you are turning the solution basic. Right. So if it is a basic solution, it turns yellow. That's correct. Yes. On passing H2S through acidified K2Cr2O7, a milky color is observed. Yes, that's also true. So that means only statement which is not true is D. So D is the correct answer. Next question. Which of the following does not correctly represent the correct order of the property indicated against it? Okay, this is interesting. Now see, I told you that in NCERT there are trends given. There are different values of properties given. So you don't need to memorize values of melting points, values of boiling points, E0 values. You don't have to memorize, but you should know the order of the melting points of elements of 3D series, you should know the order of the E0 values of +3 oxidation state or +2. So basically we have to be very thorough with the orders pertaining to these things, but we don't have to memorize values, and especially for the elements of 3D series we have to be very careful. So all of these are elements of 3D series, which is not correct. So this is just based on the data. So you look at the data given in NCERT and you memorize the orders, right? So the order of melting points, that is the first option. Yeah, so this is wrong. This is wrong. Because according to this, manganese has the highest melting point out of these. So that is not correct. Okay. Next question. The catalytic activity of transition metals and their compounds is mainly due to. Okay. This is interesting. Now see, in organic chemistry, you come across nickel, palladium, platinum. These are common catalysts used in organic reactions. So we are very familiar with these three elements. Now the main reason for catalytic activity of transition metals and their compounds is mainly due to. So the main reason is A, their ability to adopt variable oxidation states. Okay, let's move to the next question. Magnetic moment of Cr2 plus is nearest to. Okay. Now let's see. Magnetic moment depends on the number of unpaired electrons. Cr2 plus has how many unpaired electrons? So let's write down the electronic configuration. This is the electronic configuration of chromium, but it is Cr2 plus, which means I have to remove 2 electrons. I'll remove, and then I'll get this. This is Cr2 plus, right? Then for Fe2 plus, and then it's 2 plus, I'll remove 2 electrons, right? Let's find out the number of unpaired electrons for Cr2 plus. Right? And for 3d6, right? I've filled the orbitals with the help of electrons. We have followed Hund's rule of maximum multiplicity. We know that within a particular subshell, every orbital must get occupied first. That means we have to put 1 electron in each orbital, and after that we have to start pairing of electrons. And according to that I have filled, if you look at this, there are 4 unpaired electrons, 1, 2, 3 and 4. And if you look at Fe2 plus, again there are 4 unpaired electrons, 1, 2, 3 and 4. Since the number of unpaired electrons is same, I will say A is the correct answer. That means the magnetic moment of Cr2 plus will be same as the magnetic moment of Fe2 plus. Next question. Which of the following elements has the lowest melting point? So I told you again, it's a part of data. So if you look at the values of melting points given, if you look at the graph given, if you look at the table given, you will come to know, because we must be very familiar with the orders of properties for the elements of the 3D series, right? So which has the lowest melting point? Again I am repeating, we don't have to memorize the values of melting points and boiling points and other things. Values are not required, but orders are necessary. So copper is the correct answer. Copper has the lowest melting point out of these, right? Next question. Maximum unpaired electrons are present in. Okay. So these are F block elements, right? So again, you have to remember the atomic numbers of these common elements of F block, and then based on that we can find out the number of unpaired electrons. This will be the correct answer. Remember, this is extremely important. GD is very, very important, right? Very, very important. Okay. Next question. Okay, now in acidic medium, this converts to what? In acidic medium, this gets converted to Cr3 plus. This we must remember. So Cr3 plus is the correct answer. If we look at this, then the oxidation state of chromium changes from +6 to +3, and N factor of K2Cr2O7 in this reaction will be 3 minus 6 multiplied by 2. Why am I multiplying by 2? Because there are 2 atoms of chromium in one entire molecule of K2Cr2O7, and then if I take the modulus, so the N factor of K2Cr2O7 is 6. In this reaction, that means when K2Cr2O7 is getting converted to Cr plus 3, then NF is 6, and hence I will say equivalent weight. This is a very common question, so you must be thorough with this concept. Equivalent weight of K2Cr2O7 in this reaction. Equivalent weight of K2Cr2O7 in this reaction will be equal to molar mass upon NF. So NF is 6 here, so molar mass upon 6. Molar mass upon 6. Very important concept. Okay, another thing is Cr3 plus is green. Next question. Okay, which of the following metal ions forms unstable complex with Cn minus? Cn minus is called cyanide. Cyanide and Cn minus. Okay, this is what Ag plus 1. This is what Zn 2 plus. This is Cu2 plus, and this is Cr2 plus. Okay, so which of these forms unstable complex with Cn minus? Not stable, we have to identify unstable. Okay, so this is the answer, Cu2 plus. Next question. Which of the following ions does not exist? Does not exist. This does not exist. These you must have seen. V is vanadium, W is tungsten, but this you will never see. So A is the answer. This does not exist. Next question. Magnetic moment of 2.84 bm. Bm is Bohr magneton. It is the unit of magnetic moment. Right. So is given by whom? Now we have to understand this. So the formula is what? How do we calculate magnetic moment? Magnetic moment is calculated by using this formula, root of n into n plus 2 bm, that is Bohr magneton. Now what is n here? Here n is the number of unpaired electrons. E minus means electrons. Let's find out for Ni2 plus. Atomic number of nickel is 28. So this will be the electronic configuration of nickel atom, but we need Ni2 plus. We don't need nickel atom, we need nickel ion. So let's remove 2 electrons. If I remove 2 electrons from 4s, then we are left with this. Now for 3d8, let's draw the orbitals and find out the number of unpaired electrons. Right? So if you look at this arrangement, you will realize that these are the 2 unpaired electrons. Put n equal to 2 here because the number of unpaired electrons is 2. That means the value of n is 2 here. So root of 2 into 2 plus 2 is 4. So, right? 2 plus 2 is 4. That means it is root 8. Root 8 is 2 root 2. Now we know that root 2 is 1.414. So 1.41 into 2 will be 2.82. So it's approximately 2.84 bm. So D is the correct answer. 2 into root 2 is this, right? 2.8. So we got 2.8. So the correct answer is D, nickel ion. Next question. Which of the following processes does not involve oxidation of iron? Interesting one. See, we know that oxidation is loss of electrons, and also we know that if oxidation state of an element increases, that means oxidation has taken place. If I talk about option B, that is FeCO 5 times, here this is neutral, so 0 is the charge. And if I assume X to be the oxidation state of Fe, then I have to write like this: X plus 5 into 0 is equal to 0, because there is no charge on this entire structure. This means that X is equal to 0. That means the oxidation state of Fe is 0 in this. So formation of FeCO 5 times from Fe does not involve change in oxidation state of Fe. Since oxidation state of Fe has not changed, iron has not got oxidized, also iron has not got reduced, nothing has happened to iron, nothing has happened to the oxidation state of Fe. So this process does not involve oxidation of iron because the oxidation state has not changed. Hence B is the correct answer. Let's move to the next question. Again, lanthanide contraction, right? So B is the correct answer. We have discussed this already. Next, highly unstable species is, again, oxidation state is +2 for all. So basically it is about the stability of +2 oxidation state, which we can find out from data given in NCERT. So Sc2 plus Ti2 plus CO2 plus V2 plus. So this is unstable. Sc plus 3 is stable, but Sc plus 2 is unstable. So A is the correct answer. Next question. Which of the following is diamagnetic? Now what does this mean? Diamagnetic means no unpaired electron should be there in that species. No unpaired electron should be there in that species. Okay. So what is aurum? This is aurum. This is gold, right? Tungsten is W, palladium is Pd, and niobium is Nb. Right. Okay. So if you write down the electronic configuration and then check the number of unpaired electrons like we have done for some questions, then you will see that the correct answer to this is C. Pd is palladium. Right? What is the atomic number of palladium? Right? You must know the atomic number. Okay. If you remember, it's like this. After krypton, we have rubidium, strontium, tritium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, and then silver. So this is 37, 38, 39, 40, 41, 42, 43, 44, 45, 46. So Pd. So the atomic number of Pd is 46. And the atomic number of silver is 47. Right? So the electronic configuration of Pd will be, if I am interested in writing the condensed electronic configuration, then the nearest inert gas is krypton. The atomic number of krypton is 36. Right? Now, helium, neon, argon, krypton. Right? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4p6. That means till 4p6 already have filled when I am writing krypton. After 4p6 we have this, and then we have 4d. Right? So atomic number of krypton is 36. So 36 plus 2 is 38, and after 38 plus 8 is 46. Okay. So we must remember the atomic number of palladium, and after that we can write the electronic configuration. And after writing the electronic configuration, we can find out the number of unpaired electrons. Niobium has an atomic number of 41. Okay. Okay. Next question. Which of the following statements is correct when SO2 is passed through acidified? Acidified means the medium is acidic. So SO2 will get oxidized and Cr2O7 2 minus will get converted to Cr3 plus. So this is getting oxidized. That means it's acting as Ra and this is acting as OA. Right? And Cr plus 3 is green in color. So basically Cr2SO4 thrice is formed. So D is the correct answer. Next. Okay, now it is a question based on electronic configurations. This is the correct answer. It is just normal electronic configuration. Atomic numbers have been given to you. This is very important. Must remember this always. Exceptional electronic configuration. So D is correct. Very, very important. Take care of this. Gadolinium. It's important. You must remember. Next. Lanthanon means lanthanoid, which is incorrect. Which of the following statements is incorrect? This is incorrect. Aluminum is more reactive. So A is incorrect. All the lanthanoids are more reactive, so that's wrong. Next question. Which is ferromagnetic? Now ferromagnetism means highly that means it has a very large number of unpaired electrons. This will be the answer. Cobalt is ferromagnetic. Next question. Aqua regia converts. Now what is aqua regia? Aqua regia is a mixture of concentrated HCl and HNO3. Okay. It converts Au to AuCl4 minus. So aqua regia is used for cleaning gold. Next question. Which of the following can convert Cl minus to Cl2? Now see. If Cl minus is getting converted to Cl2, that means the oxidation state of Cl is -1 here. And here it is 0. That means Cl minus is getting oxidized. That means this is acting as Ra, reducing agent. So with this you need some OA. Right? Now this is a very good OA, hence A is the correct answer. Remember, KMnO4 and K2Cr2O7 are strong oxidizing agents. They are very good oxidizing agents. So A is the correct answer. Next question. Which shows yellow color? Which shows yellow color? This is very interesting. You have to remember that C plus 4 is yellow. C is cerium. Atomic number is 58. Very, very important concept. C plus 4 is yellow in color. Okay, name the gas that can readily decolorize acidified KMnO4 solution. Just now we discussed that KMnO4 and K2Cr2O7 are good oxidizing agents. So, if KMnO4 is acting as an oxidizing agent, then some other species must act as a reducing agent. Oxidation state of Mn is plus 7 here, it will undergo a decrease in oxidation state, and here oxidation state of sulfur is plus 4, this will undergo an increase in oxidation state, so I'll say SO2 is getting oxidized. That means SO2 is acting as reducing agent, and that means the reaction is taking place, it's a redox reaction. So I will say that acidified KMnO4 solution is getting decolorized because this is colorless. Mn2 plus is formed when the medium is acidic, right? And SO2 is getting oxidized to sulfur having higher oxidation state. Let's say plus 6. So some species where sulfur has a higher oxidation state. Higher than plus 4 means plus 6. Okay. So, very important concepts have been covered, right? Please go through all the reactions of KMnO4 and K2Cr2O7 given in NCERT. Also, you must be thorough with the structures of CrO4 2- ion and Cr2O7 2-. That means we have chromate ion, that is CrO4 2-, and Cr2O7 2- is dichromate. You have to be thorough with the structures of these. Right? So this is CrO4. CrO4 2-. This is the structure of CrO4 2- and Cr2O7 2- is this. Right? So these are very important. Now here all the CRO bond lengths are equal. Because of resonance we'll have identical bond lengths here, here, here as well as here. That means all the 4 Cr oxygen bonds are of equal length here, but here it's not like that. These 3 are of equal length, 1, 2, 3 and so 6. So 1, 2, 3, 4, 5, 6. So here we have these 6 CRO bonds which are of equal length, whereas this and this are of different length as compared to this one. That means there are 2 types of CRO bonds in this, whereas here there is only 1 type of CRO bond. So this is very important. Okay. So here we have 2 types of CRO bond. One type is this and the other type is this. Here we have all same CRO bond. So there is only 1 type of CRO bond in CrO4 2-. Okay. Thank you.